Welcome back. We're in Chapter 2, where we'll be talking about research methods in IO psychology. In this first section, I'm going to talk about science and theories, and then in the next section, in the next video, I'll talk about some of the methods that are available to us and ethics and things like that. All right, so let's get cracking. All right. So what is science? The strict definition, a process or a method for generating a body of knowledge. I italicize process and method because a lot of times people think science is determined by what your subject matter is. And so some people think, for example, that there's something substantively different about psychology than as a science than they're compared to like chemistry or something, geology. While we study different subjects, different topics, different materials, our methods and our processes are the same. So psychology is a science. So the logic of inquiry is a method that increases understanding of concepts, of processes, and relationships. So when we talk about science, we're talking about engaging in a method of inquiry that's going to allow us to understand more about whatever our subject matter is. In our case, we're going to be interested in human behavior and mental processes with regard to work and work-related issues. So is psychology a science? Yes. I try not to sound as defensive as I feel about this issue because, of course, psychology is a science. It's shocking to me that people think it's not. But the reason why we know that it's a science is that it relies on formal, systematic observation, and that it allows us to answer questions about behavior and mental processes as our subject matter. So it's the process, it's the method that we use that's important, not what we're studying. So there are four main goals of the scientific method: describing a phenomenon, explaining a phenomenon, predicting when a phenomenon is likely to occur or not, and then ultimately controlling the phenomenon. So when we say description, what we're talking about is having an accurate portrayal or depiction of a phenomenon. So in the description phase, we're trying to really establish what exactly that phenomenon is, right? Like at the descriptive phase, we might be interested in knowing the intensity of the thing that we're measuring. You know, how much motivation does a person have, or we might be interested in how often a behavior occurs, like calling in sick or something like that. We're just describing. We're not trying to say why a person's calling in sick. We're just trying to establish that they are, how often they are, things like that. The next phase will be the explanation phase, where we are trying to figure out why the phenomenon exists or what might possibly cause that phenomenon. So now we might be trying to figure out, okay, what makes it more likely that an employee might call in sick? So we go a step beyond that description and start trying to generate explanations or hypotheses about why that happens or what might be causing it. That takes us to the prediction phase, where we're going to try and anticipate an event that hasn't yet occurred, and we're going to try and figure out what factors contribute to it actually occurring. Right, so we're going to try to anticipate that event and think, okay, so let's look around in the environment and see what seems to precede an employee calling in sick, right? And see if that event consistently precedes that behavior, right? So we're going to try and predict what factors go into an outcome. And then the control phase, this is the ultimate last step in science, is manipulating the conditions so that we can try and affect behavior. So we may have developed through, okay, so sometimes people call in sick, description phase. Maybe they're calling in sick more often when they have childcare issues. So now I'm going to make and that's at my explanation phase. Now at the prediction phase, I might say, start keeping track of times that I become aware of a childcare issue, and then whether it's followed by my employee calling in sick. And then ultimately, I might try and get control over it, which is an issue that's relevant to IO psychology. Maybe I'm going to start offering a childcare facility right here on site and see if that reduces the likelihood that employees call in sick. If after the prediction phase, I've come to the conclusion that childcare issues are a #1 factor in employees calling in sick, I'm going to try and control that by actually manipulating the conditions. Oh, you don't have a reason to worry about it. We have childcare here. So the goals of science, you kind of move through those stages. And the thing that's really important to remember is that not all questions in psychology can be answered through the control phase. There are certain things that we don't have control over, so we can never really get to that phase. So it's not always the case that we'll have control, but we will try and move through at least the first 3 in almost every question that we talk about in this subject of IO psychology. All right, so there are 3 major assumptions of science. One is empiricism. The idea in empiricism is that we are going to gather data. Out of that whole big long thing that I wrote there, really the key little clause is that gather data part. We're going to gather data and use that data to test our predictions. So we may have some kind of expectation based on a theory in psychology, and so we make a prediction based on that theory. So for example, in self-determination theory, we say that people will strive for autonomy, right? That's what the theory predicts. So I'm going to say from that theory that I'm going to predict that employees who are given the opportunity for autonomy will express greater job satisfaction than people who are deprived of feelings of autonomy. So based on self-determination theory, I generated a testable hypothesis, and then now I have to gather data and see whether that hypothesis is supported or not. That's what we call empiricism, right? Where we let the actual data determine whether our prediction was supported or not. Another assumption of science is determinism. This is a really crucial assumption of science, that behavior is orderly and systematic, that there is a cause for the behavior that we're observing, whether it's a behavior or a mental process. Something is causing that to happen. Now, you may have been introduced to the term determinism in philosophy, where it's about sort of ultimate causation, like a creator or something is in charge. We're not talking about it like that with science. What we're talking about is that there is a cause for behaviors. And this is sort of a really super necessary assumption, because if behaviors just happen and there's no cause, then there's no way that we can move through the explanation and prediction and then ultimately control phase of science when talking about human behavior, right? So we have to assume that behaviors are being caused by something, and that something can be discovered. Discoverability is our last assumption, right? That behavior can be experienced, examined, and discovered. We can figure out what that ultimate cause was for that behavior. If we are clever enough, if our study is designed well enough, we can ultimately, through our empirical data collection, discover those causes of the behavior. And that's really important, because if we can't figure out why our employees or our coworkers or our bosses are acting the way that they are, we can't really adjust our behavior. We can't, change their behavior through the rewards or punishments that we dole out. I mean, there's nothing we can do if we can't figure out what determined that behavior and we can't discover that, right? So these really key assumptions of science, empiricism, determinism, and discoverability, are what make it possible for us to do science. All right. Hopefully this little discussion of what science is not news to you, so I'm doing it a little bit quickly. What is a theory? Sometimes I have students kind of gloss over their definition of a theory, and so I do want to spend a second talking about theories, because they are not just sort of folk theories, right? The folk theories are where we've sort of looked around and picked and chose what parts of the environment we're going to notice, and then we kind of come up with an explanation for why it is the way that it is. That's not what we're talking about in scientific theories. We're talking about a systematic view, which explains existing phenomenon and predicts an existing phenomenon. So when we're talking about a theory, we're talking about something that is based on data that has already occurred and makes predictions about what other data is likely to be discovered. It explains the phenomenon in question based on the data that we have so far, and in that explanation extends out to what we should expect to find next. Now, every theory contains constructs, or what you might have learned as the term concepts. These are things that are not directly observable, but we all kind of know what they are, like intelligence is a construct. It's not directly observable. You know it when you see it. You know it when it's not there, right? But it's not something that's directly observable. It's something that has to be sort of inferred from other behaviors. It's kind of hard to explain what a construct is, isn't it? It's got to be operationally defined, is what a construct is. So when we are looking at a theory, or we're generating a theory, it needs to define the aspects that it's going to be dealing with. And it oftentimes needs to operationally define some of these concepts, because if this is something that doesn't actually concretely exist in the world, we have to figure out a way to measure something that can stand in for that concept. So sticking with intelligence, we have intelligence tests that may not be a perfect measure of all the concepts or constructs that you would include in the word intelligence, but at least that number can stand in for this abstract concept called intelligence, something that isn't directly observable. So we have to come up with operational definitions that would allow us to measure at least some aspect of that construct, and that therefore we can use those operational definitions to help us move forward in our theory. Theories always contain propositions. Propositions are proposals, basically, right? Where in a theory it says, given the data that we have so far, I propose that this is the reason why it is organized the way that it is. I threw out self-determination theory earlier, so let me expand on that for a second. In that theory, the idea is that humans have intrinsic motivations that are inside of us that make us want to pursue them. So one intrinsic motivation that self-determination theory offers is that we have a need for autonomy. We want to feel like we are self-governed, self-directed, in charge of our own destiny. Another intrinsic motivation that they offer is affiliation, that we want to belong, that we want to be connected to others, things like that. That's just a little scratching of the surface of self-determination theory, but the idea is that it proposes that we have these intrinsic drives, right? And it names a few. There's a total of 5 that are named. And that these intrinsic motives are going to govern our behaviors, and that we should be able to see differences between people on these intrinsic motivators. We should be able to see the outcome of these intrinsic motivators, right? Like these are all the propositions that are included in self-determination theory. Any word where I put, anytime I said should, that's a proposition. Right, so we should be able to see evidence of these. We should be able to see differences between people. That's what a theory does, is it tells us, here's this construct, this hard to pin down idea. Let me define it for you. And then here's how it should manifest itself, or this is how we should think about it, or how it might affect other behaviors, stuff like that. So theories are based on existing data, and then they allow us to make predictions for future outcomes. So the constructs and the definitions interact with each other. The definitions and the propositions interact with each other. All of these things are all connected together in a theory. So what makes a good theory? Well, first and foremost, it needs to be parsimonious. You guys might remember the principle of parsimony, or sometimes it's referred to as Occam's razor. The simplest explanation should be assumed to be true, is the definition of the principle of parsimony. Basically, this principle tells us that simpler is better. To be able to explain a phenomenon without having to invoke a lot of extra mechanisms is a really good parsimonious theory. I'll give you an example of a not good parsimonious theory, a non-parsimonious theory. Freudian theory describing pretty much, well, I guess pretty much all of Freudian theory, right? The idea that we have to invoke an unconscious in order to account for some of your behavior. We can't even find, where is your unconscious? We can't quantify it. We can't establish it. It's, what is it, magic? I'm being a little extra skeptical, but just go with me. Where is it? How does it work? How big is it? We don't know, because it's something you can't even look at. It's not the simplest explanation for people's behavior. The simplest explanation for people's behavior is that they're reacting to what's happening right now, not that they're carrying around with them repercussions from their childhood. That's an extra step, right? The simplest explanation is that you're reacting to what's going on right now. Now, please don't construe this as me saying that that's the correct interpretation. I'm just saying it's the simplest explanation. So the simpler the explanation, the better the theory is, because there will be fewer things, little mechanisms that have to be invoked in order to make the theory work. It's precise. We need a theory that is very specific and accurate in its wording. Now, if you've ever read an article where somebody is laying out a new theory, sometimes they're so specific and accurate in their wording that they say the same thing multiple times to the point where you're like, I already get it. Why do you keep repeating yourself? But they're trying really hard to make sure that nobody could misconstrue what they mean by their terminology or things, being super precise. It could be precision of language. It also could be precision of what kinds of phenomena would be covered by this theory. Like, I might want to be really precise that really I'm only speaking about human behavior in the workplace. I'm not trying to say that this would generalize out to school, or that I think this generalizes into how people behave with their friends. I'm being very specific in my theoretical design, and I'm talking only about work behavior, right? That would be useful to know whether you're talking about human behavior or you're talking about human work behavior, right? So being really super precise. Theories need to have aspects that are testable. Like, the whole theory can be kind of conceptual, right, based on constructs and things. But we should be able to generate testable hypotheses from a good theory. So we should be able to come up with predictions. Okay, so I read my self-determination theory. It said that some of us are motivated most strongly by the need for autonomy. I should now be able to make a prediction that people who are driven by the need for autonomy will behave in this way. And then I should be able to test that, right? If it's a good theory, it will very easily lead to testable hypothesis generation from it. It should be useful, right? If you've developed a theory that accounts for something that nobody really cares about, it's like nobody's going to care that this theory was generated. But if you have a practical, helpful theory that really describes and explains and predicts important phenomena, now it's going to be a good theory, something that will actually last and that people will want to do research to test and things like that. So one of the things that's been nice about self-determination theory is that it has been useful. Knowing that people are motivated by different things can really help a boss to use whatever is the motivator for their employee to help keep them engaged in their work behaviors. I used self-determination theory when I was managing a group of Girl Scout leaders. I was the service unit manager, and there was a pretty frequent complaint by some of the leaders that the things that they thought the troop would want to do, it turned out that a substantial number of the girls didn't want to do that. They wanted to do something else. So, for example, I had one troop leader who wanted to work on badges, and all her girls wanted to do was just talk. And, I thought you guys were in Girl Scouts to earn badges. So one of the things I did with the leaders is I gave them one of the tests that can be used to determine what intrinsic motivator is your primary motivator. And the fact that all the leaders scored differently on these 4 characteristics showed that, people vary on this. So some of them scored really high on competitiveness that might fit into to wanting to do badge work, right? Others scored really high on affiliation, which would, correspond to wanting to talk to your troop mates rather than working on badges, right? So once the leaders saw that there's this concrete thing that we might differ on, and it was all explained by this self-determination theory that I didn't bore them with. I just gave them this little personality test and said, see how we all differ? That might explain why, your girls all differ, right? It's not that you're doing something wrong or whatever. It's that they have different motives, right? It's helpful. For them in that situation, it was an important phenomenon. Here I am having troop meetings, and they don't want to do what I thought that they wanted to do. You can imagine this in the workplace. If you think that your employees are motivated by competition, for example, wanting to do better than their peers, and the truth is that they're motivated by affiliation, you might actually just directly be running in the face of what they really want to be doing. If you're trying to pit them against each other and get them to compete because you think that's what's going to motivate them, and the truth is what they want to do is bond with each other and have group cohesion, you may be actively undermining their work motivation. So having a theory, self-determination theory is my favorite theory to do research on, but having a theory that can account for useful phenomena is an important thing. Having a theory that just explains stuff and organizes data that nobody really cares about, it's not very useful. It's not going to be a very good theory. And then finally, the last and maybe most important thing is that it's generative. A good theory is a theory that people want to study, right? They want to find out whether this aspect of the theory is supported by their data, or that aspect of the theory is supported by their data. I mean, it makes researchers want to do research on the question. And that's, the whole function of science, right, is to keep building on each other and growing and getting new information. So having a good theory that fits all of these criteria is really super important for moving science forward. Okay. I think it's a good time to take a break, and we'll come back in the next segment and we'll talk about the actual research process and the different methods that are available to us and a little statistics. Not too much, don't worry. Okay, I'll see you in the next video.